In this video, I will be going to discuss contextual compression retriever. So basically what it will do, it will refine the retrieved documents. So it will not give the documents or the shortlisted or relevant documents as it is. It will refine it by using an LLM to remove irrelevant context and keep only the parts which are most relevant to the user query. So what does that mean? Suppose you have got some shortlisted documents. So these are the shortlisted documents which are relevant to your query. Now this contextual compression retriever refines the retrieved documents. So these documents which are retrieved, it will just give only that portion of the text from here which is actually relevant for your query. So this retriever is useful when you have mixed and long documents, and in a single document multiple topics are discussed or multiple contexts are discussed. This is what I have written here. So in a single document, more than one topic or context is discussed. So in those kind of cases, retriever is useful. So let me show you one example for better clarity. I have this list of document. For example, this is document 1, this is document 2, and so on. So here I am talking about LangChain, and after that embeddings, and then Great Wall of China. In the same way, here some technical things about retriever is discussed, and after that Himalaya mountains are discussed. Then you see, again it is something talking about LLM, and then Mumbai is discussed. Then here also coffee is discussed, and here some technical things are discussed, and in between Eiffel Tower is discussed. Here I have used a very small document, but when your document is very big, there can be a mixture of different context. So what I want is, I don't want the whole document, just I want the relevant portion from that particular document. For example, this is my query. How does LangChain use vector database in its architecture? So let's suppose this is shortlisted, like it is talking about LangChain and this question is about LangChain. So most likely this will be shortlisted, but it is also talking about coffee beans as well. So I want this answer only. I don't want anything related to coffee bean, and I do not want related to machine learning also, because I am using the vector database architecture or embeddings. About embeddings I am asking, so this statement is fine. Because the normal vector store retriever will give you the full document, but contextual compression will give you refined results. So how it works, let me tell you. So you have your query and you can use any retriever to shortlist the documents. Your retriever can be vector store retriever and MMR retriever. Suppose you get 3 shortlisted documents, document 1, document 2 and document 3. After that, what will happen? All these documents will be again sent to LLM along with this query. So this query and these shortlisted documents will again be sent to the LLM. Then what this LLM will do, it will be going to extract the relevant text from that particular document based on this query. So this will also do the same thing and this will also do the same thing. So in this way, I will be able to get the refined document. So what is this LLM? This LLM I will mention in my coding. So this is what I have written also. First, a normal retriever like vector store and MMR find the most relevant documents based on the query. So you have extracted it. However, those documents may still contain extra and unrelated information. So that's fine. And then these selected documents is passed to the LLM along with the original query. So this is your original query and these documents are passed to the LLM, and the LLM will keep only information relevant to the query while removing the rest and this process is known as compression. Now I will show you practically how to implement contextual compression retriever. So I have created this file. You see, I am copying some code which I have written already. So I copy the code from multi-query retriever and paste it here. So I am using FAISS. I am using these two classes, OpenAI embedding and chat OpenAI. I need the document class also. So also I have loaded the API keys, but here I don't need this particular retriever. Instead of that, I need contextual compression, and here I will be going to import contextual compression retriever. So this is the one change I have done. Also from LangChain dot retrievers, I will use document compressor, and from that I will import LLMChainExtractor. This LLMChainExtractor will be able to extract the refined text from the shortlisted documents. Now I have defined my LLM model. I just call it LLM, that's fine. And this is the embedding model I'm using. And after that, I need the list of documents. So you see, I already have this list of documents. So I will copy all these documents along with this query. So I copy it and go to Visual Studio and paste it here. So the whole document is pasted. Now you see, using the FAISS, I will be going to generate the embedding. So you know the command, you have to do from documents, and here you need to pass the documents. So that is the list of documents, and you have to pass the embedding. So my embedding is equal to embeddings, which is this. So you see, I will equate it with vector store object. So you see, this will create all the embeddings for all these documents, and it will be stored in memory. After that, I will be going to create one base retriever. So that will be vector store as retriever, and I'm not passing any argument. So by default, the value of the k will be 4, and it is a normal vector store retriever. So that will act as my base retriever, and this base retriever will basically shortlist the documents of my query. After that, I need this LLM chain extractor. So you see, I am using this LLM chain extractor, and here I will be going to use the function from LLM. If you remember, in the multi-query also, when I used multi-query retriever, during that time also I used from LLM. So this is the same function I'm using, from LLM, which is present inside LLMChainExtractor, and here it is asking me which LLM model. So you see, I already have the LLM model, which is GPT 3.5 Turbo. This is LLM, so I will equate it with LLM. That's fine. What is the purpose of this LLM chain extractor? It will extract the refined text from the shortlisted document, and the process of extracting refined text from the shortlisted document is known as compression. So I will call it as compressor object. So the compressor object is created. Now I will be going to use this class contextual compression retriever. So I will write contextual compression retriever, and in that I need to fill here base retriever and base compressor. So first I will be going to fill the base retriever. So base retriever is this base retriever object which I have already created. So this retriever will be used to shortlist the contents. You can use MMR also if you want, but right now I'm using the vector store retriever. And then you have to use the base compressor also. So base compressor I have already defined, which will be going to extract the refined data from the shortlisted document. So that is equal to compressor object which I have already created. So that will be equal to my retriever now. So that's fine. And now I will be going to invoke the retriever, and I will be going to pass my query to the retriever to get the result. And now I will be going to display the result. So to display the result, I am just copying the same command from the multiquery.py and paste it here. So instead of result1, I will be going to do result, and I will be able to display the result. So if I run this now, so here I got the results. So if you notice, in the result one, I am getting LangChain allow integration with multiple vector databases such as FAISS, Pinecone and Chrome. I copy this result, and you see I go there and do Control F and I paste this. So you see this particular line is selected out of the shortlisted document and the rest of the text is ignored. Let me copy the result too. I copy and paste it. So you see this is the middle line which it has extracted from this particular document. Let me copy the third result. Copy, paste. So this is the first line which is extracted. So you see it has ignored this coffee bean line. And if you check the fourth one also, I copy and paste it here. So you see it has extracted the relevant context and it did not include Eiffel Tower or some information about OpenAI APIs. So that's good. So in this way you can implement contextual compression retriever.